In this Algebra 1 video, we're going to be taking a look at what we would call an inequality and how they can be used in our equations like we did in the previous video. So let's go ahead and let's take a look at what an inequality is. So, if I wanted to represent one side of an equation, keep in mind that an equation would be two pieces of information separated by the equal sign, two expressions on both sides. If I wanted to represent if one side was greater than the other, how would I do that? Well, if it's an equal sign, we know that means they are equal to. So with an equality, what you can do is you can use kind of like an open arrow to represent greater than. So this is an inequality, and it represents greater than. So greater than. I like to think this as if this is like an alligator trying to eat the biggest number. And since within algebra, when we read left to right, we know that we're comparing this first number. So for example, let's say we had an equation like this. Well, since we're reading left to right, we know that, okay, this first piece of the equation must be greater than the other side because the alligator is trying to eat the biggest number. And similarly, we can do less than. A backwards version of this would be less than. So in this case, the alligator is going for the smaller number. Since we read left to right, this is smaller than, and this first or the second number right here is a bigger number. This means less than the first number. So then similarly, if we wanted to represent, well, maybe we don't want the number greater than, we can, well, it can be greater than or equal to. We don't want it to be less than, but we want it to be maybe greater than or equal to the number on the other side. So this would be represented with first our open, kind of like an arrow, whatever you want to call it, with a little underscore underneath. This means greater than or equal to. So any of these conditions can be met. So this means that this number on this side can either be greater than this number or it can be equal to. And you can also do it for less than. So this is less or equal to. So we can have, just like this, we can have less than or equal to. So let's take a look at when we might go ahead and use this in a real problem. Say we had 4x plus 2 is less than 16. And we want to check to see if this condition really is true. So how are we going to go ahead and do this? So let's say we are solving for when x is equal to 4. And we're going to be solving this equation as if this was an equal sign, but we're only checking to see if this is true. So let's go ahead and let's plug in the 4. We have 4 times 4, because we're substituting for x, plus 2. You have to bring that down, and we're seeing once again if that's less than 16. So, well, 4 times 4 is 16, and of course we have to add the 2, and that's going to be 18. Well, since this side is 18, and we're seeing if it's less than 16, this is not true, because 18 is not less than 16, so this inequality is not true. X cannot be equal to 4 to solve this inequality. Let's take a look at another example. Let's underline that. Let's say we had 3x plus 4 is, well, let's get rid of that. 3x plus 4 is greater than 8. And we're going to be solving when x is equal to 3. So let's go ahead. Let's plug in for x. So we have 3. We're multiplying that by 3, where we put in for x, plus 4, and we're seeing if it's greater than 8. So 3 times 3, that's going to be 9. And then we have to add the 4. Well, that's going to be 13. And yes, 13 is greater than 8. So this is true. Very important that you can distinguish when they're less than or greater than. So when x is equal to 3, yes, 3x plus 4 is indeed greater than 8.